So here we go. All right, so chapter 3, lesson 3, we have polynomial identities. This is a 2-part lesson. Today is going to be significantly easier than tomorrow. Tomorrow is definitely new information for you, but we need to talk about all of these factoring techniques before we can talk about tomorrow and get into tomorrow. So I'm going to have you do the evens for homework. So on the top of your paper, why don't you just write right now, homework, evens. I think we're good. So GCF, we've talked about GCF a lot because it's come into play a lot. A common number and a common variable. So I want to have 12 and 10. So I think like, what's the biggest number that goes into both of them, right? That's what it is. So that's a 2. Now, again, if you guys want to volunteer, you can. There's a lot of information that's going to be new that I'm just going to share with you and do for you. So if I see your hand raised, I will call on you. And if not, then I'll just go. A's, let's go back to number 1, the A's. How many A's do they both have? Like they have to have a common variable, and they do. But how many of the A's? It's squared, A squared. So it's going to be (2a squared, parentheses, 6a plus 5. And then remember, you got the evens. So. Okay. Number 3, difference of squares. First of all, what are perfect squares? Numbers that multiply times each other, and they also are perfect square roots. 1, 4, 9, 16, 25, 36. But honestly, since we're like dividing out, you might not even go higher than 36 or 49. But you know, 2 squared, 3 squared, 4 squared, 5. The rule is difference means that there's a positive, a plus sign, and a negative sign, but the numbers are exactly the same. Okay, the numbers are exactly the same. All right, number 3. I need to look at the 9 and the 49, perfect squares. The x squared is a perfect square, x times x. The y squared is a perfect square, y times y. 3x plus 7y, 3x minus 7y. My a is the 3x and my b is the 7y. So I got the, a plus b, a minus b, like that. On number 5, okay, there's a GCF. So now I've got a combo. I got to do GCF and a difference of squares. And I want you to look for GCFs kind of as a preliminary check every question. Because even like number 4, you're going to do it tonight. They're both even numbers. So you have to take 2 out first. And then you'll see that your problem becomes a lot easier. Okay. So a 7 for sure is the number that's in common. But then there's like, well, how many m's do they both have? Well, for sure they have an m. 1. How many n's do they both have? End of the first, end of the third. They both have 1. Okay. So here we go. When I factor out a 7mn, I am left with m to the 6th minus 4n squared. So, by the way, if I'm going through something and you don't understand how I got the 4n squared, for example, then you need to like bring that up to me and let me know so I can explain to you, because I divided out a 7 out of 28, an m to the 1 out of m to the first, an n to the first out of n to the third. Okay. But now I'm not done. You know how when you do like m cubed times m cubed, you add 3 plus 3? Well, that's what's going to happen here. I'm going to have my 7mn, and then I'm going to do m to the third plus 2n, m to the third minus 2n. My a was m to the third. My b was 2n. Like a plus b, a minus b. All right, this is where I think it might be all new for you. A sum of cubes. A number is a cube. Like here are the cubes. My pencils are just not sharp enough. I feel like I really should be switching to mechanical pencils here. 8, 2 to the third. 27, 3 to the third. 81. Oh, no, 64, hold on. 64, 4 to the third. And actually then it's not 81 at all. 3 to the fourth is 81, which, sorry. 125 is another one, but that's a really huge one, so I don't know. Okay, here's my rule. It's a pattern. Have two sets of parentheses. The first set of parentheses is my a value plus my b value. And then you write them separately. You don't actually like combine them. You leave them with the plus sign in between. Then I have the first a value squared minus a times the b, the two numbers multiplied, plus b squared. So let's go slow. My a is obviously going to be x. My b is obviously going to be 3. I can also say that my a is 1, but what you know. Here we go for number 7. Okay, a plus b, x plus 3, a plus b. Then a squared, x squared, minus a times b, x times 3. I'm going to put 3x. The number goes in front, the coefficient, right? Plus b squared, plus 3 squared, plus 9. I leave it. I can't factor this trinomial. It seems like you could because it ends in a 9, but you actually can't. You leave it just like this. So 9. There's a GCF, you guys. On number 9, there's a GCF. It's 4. 125, a to the third plus 1. Which means that my a is going to be whatever makes 125 like 3 times, and a to the third. Does somebody want to tell me what the a is for number 9? This is a good volunteer question. Katie?
5a.
It sure is. And then b is obviously 1. Okay, here we go. 4 times the quantity, 5a plus 1, a plus b. Then a squared, 5a squared. Okay, 5a times 5a, 25a squared. So it's like this, 5a squared. I have to square 5 times 5, and then I have to do a times a. 25a squared minus a times b multiplied together, 5a, plus b squared plus 1 times 1 plus 1. So since a had a variable and a number, I had to square them both. So keep that in mind. Like it looks like this. It's not just 5a squared. It's the whole thing, 5a times 5a. Okay.
Why is the A 5A?
Because I had to think of what number 3 times makes 125. 125 is a perfect cube. What times what makes 125? Because isn't this something cubed plus something cubed? 125 is a number, 5 times 5 times 5. And then the 1 is 1 times 1 times 1. So it's kind of like doing what's the third root of 125? You could maybe think of it like that. Does that help? I don't know. Maybe. But then, of course, it also had the a to the third in it. So you have to, you know. It's like, what if you guys, I'll do it on the side. What if I had like 64 c to the third? What would be my a? Does anybody want to volunteer?
4C.
4c. Yep. Because I cubed root the 64c to the third. So it's all like what times what makes the number. Okay. 11. Difference of cubes. A minus b. Then a squared plus a times b plus b squared. So it's switched. The subtraction sign. Okay, look at sum and difference of cubes. We have to talk about here. I had a plus sign in my first parentheses and my leading sign, first thing I did was a minus. Here it's just switched. So this is what I had for sum of cubes. It starts out with a sum, you add them, and then your negative sign is in your trinomial here. For difference of cubes, I start out with a subtraction here, and then it's positive both inside the parentheses. Okay. X cubed minus 1. My a is x, my b is 1. So first I start out with like a minus b, x minus 1. Then I've got plus signs the rest of the time. And here's a, here's b, x squared plus 1x plus 1 squared is 1. So it's x minus 1, and then x squared plus, you could just write x, you don't have to put the 1 there, plus 1. $13. Is there a GCF on 14? On 13? Is there a number in common? Four goes into 4 and 4 goes into 32. 1 minus 8h to the third. And 8's the perfect square. 2 times 2 times 2. So here we go. The 4 stays out there. My a is 1. My b is 2h. So a minus b. 1 minus 2h. It's fine that it's written backwards. The ordering, you just look at what I've got. It just happened to be that my exponent came second. It's fine. Does not make the problem more difficult. So 1 minus 2h. Then I got a squared plus ab, 1 squared plus a times b is 1 times 2h, plus b squared. That's 2h times 2h. Think carefully. 2h times 2h. 2h squared. 4h. So that's where I got the 4h squared. Sorry, my finger was blocking everything. 4h squared. Oh, jeez. I'm trying to rush and then it doesn't look very good. Okay. These are all properties of exponents. Like if this is something that you don't know, look at my fingers. If you don't know how to do that, then that's a skill, it's like a prerequisite skill from before, and I can just remind you, but gotta remember the next time, you know? Okay, sum of a square. I think you guys already have this, but I'm making it much more difficult. So you're gonna FOIL. You're just gonna write it twice. And I'm gonna do 3x times 3x. So it's basically, here it is, 9x squared plus 24xy plus 16y squared. 9x squared plus 24xy plus 16y squared.
How did you get 24xy?
I did. Let me do it on the side. So when I FOIL, I get 9x squared. And then the inside outside is 12xy plus 12xy. Last was 16y squared. So the 12xy and the 12xy go make the 24. So when you order this, okay, it's alphabetical. But obviously something like an a squared would be leading. And like, let's say I had like even a C or a D, like that would still go, I could put that in the middle. But then if I had like an alphabet letter after D, then no matter what exponent it is, that would be alone. So like E squared. So something like that, you would, that's like the ordering. There's some rules to the order. Okay, I'm going to the back side. You know what? There. Okay, this is just factoring normal, except I'm giving you an n squared, which means I'm giving you an n to the fourth, which means I'm going to put n squareds there. Okay. And then it's what two numbers multiply to make negative 24. So if you like this x thing, I don't know, maybe you do, but add up to positive 2. 6 times 4, right? 6 and 4. But I want a positive 2 when I add them. So that would be a plus 6 minus 4. Oh, n squared minus 4. That's a difference of 2 squares. So here's my final, right? N squared plus 6 again. And now I'm going to factor the n squared minus 4. N plus 2 and minus 2. So I have 3. N squared plus 6, n plus 2, n minus 2. 3 factors. Like 16. You're going to have to do this for homework. You're going to have to factor a w first. 18. You're going to have to factor an x first. Mm, 20 is going to be fine. Okay. Oh, I'm going to go to 17 now. They all have an A. They're all even numbers. 2a. A squared plus 19a plus 34. Okay. 2a stays in front. So two numbers that multiply to make 34 but add up to 19. A plus 17, a plus 2. $19. The only thing that maybe should like make you think for a second is that you just have an x to the 4th in front. So it's like, obviously one of them is going to be a 3x squared and one of them is just going to be an x squared. And then you have to figure out x squared plus 5, 3x squared minus 1. Okay, we're getting down to the wire. I'm crossing out 23 and 24. Okay. All right. Grouping. Grouping means that I've got for sure 4 terms, and I need to split up those 2 terms into things like 2 things. 2 of my terms will have a matching factor, like a variable or a number. And then my other 2 terms are going to have a matching factor or number. So I always like to draw this like line straight down the middle. And then I do x cubed and x squared. What is in common? Like what can I take out there? So that's going to be an x squared. And then what's left? An x plus 1, right? So I'm factoring out the common factor, GCF, just the first 2 terms. Then I look at the second 2 terms. I've got a negative 4x and a negative 4. Well, negative 4 is my common factor, but it's going to be x plus 1 in the parentheses. It is no coincidence that this x plus 1 and this x plus 1 are the same. It's supposed to be like that. In fact, if it's not that, you did something wrong. So now I'm going to put what's in common, the x plus 1, that's there. Okay. I only write it one time because I'm pulling out the common factor. Now, when I cover up my orange, I have an x squared minus a 4, right? That's left. That gets put together, and that is a binomial, x squared minus 4. But again, your brain still has to be thinking, can I go further? Is there anything else I can do? Yeah, there is. So I know that x squared minus 4 can be factored. So x plus 1 is still going to stay because that's my common factor from the beginning. And then x squared minus 4 is x plus 2, x minus 2. I have 3 terms. Okay, last one we're going to do as a group is 21. Cut it in half, right down the middle, because I'm going to see that there's common factors in the beginning, common factors at the end. This one's very similar to my example. So x squared comes out and I have x minus 1. Then out of my second set of, my polynomial, I have 9 in common. Plus 9, x minus 1. This common x, yeah.
Well, so for 21, you said it's gonna be. Oh, never mind. I did because
So,
I thought we were supposed to factor out -9.
oh, not on this one. A little different.
Okay.
X squared plus 9, nothing happens to that. I can't go further than that. But my comment that I wrote, x minus 1, I need to write 1 time. The order doesn't matter, because if you want to put x minus 1 at the beginning, that's fine. That's what I did on my example. I should have. Okay. All right, so your job is to do the evens. Okay, hold on, stop recording.